Hello dear student, I am Monir Islam. Today in this video we are going to discuss an important question of GATE 2022. Okay, this is basically question from real analysis and it is question from in sequence. Okay, what is the question? The question says the real sequence generated by the iteration scheme xn equal to xn minus 1 by 2 plus 1 upon xn minus 1 greater than n greater than 1, and there are 4 options. Okay, so we have to check the 4 option one by one, right? So see, first of all, what is the scheme given? Xn equal to xn minus 1 upon 2 plus 1 upon xn minus 1 n greater than 1, right? So from the scheme, obviously it is given that xn is a sequence of real number, means xn belongs to R for all n greater than 1. Okay, now if you put n equal to 1 here, so x1 equal to x0 by 2 1 upon x0. Okay, right? From this it is clear that x0 never 0, x0 never 0, and it is a non-zero real number. x0 is a non-zero real number, because if it is 0, then 1 upon 0 is infinity, it is undefined. Okay, but it is a real number, or it is also a real number. So one side is real number, one side is infinity, and one side is real number. It is not possible. Okay, so x0 never 0, x0 never 0. Okay, so see, there are option says converge to root 2 for x to 0, non x to r minus 0, x0 greater than root 2 by 3, x0 belongs to minus 1, 1 open minus 1 open 1, x to 0. Okay, diverge for x to non-zero. Okay, these are options. In all options says x0 non-zero. Okay, x0 must be non-zero. Now, so we have to check for non-zero real number. Okay, we have to check the conversion of the sequence or divergence of the sequence for non-zero real number. Okay, so first of all, I am coming in fourth option. Okay, it says that a divergence for any x non-zero. For any x non-zero, this scheme is divergent. The sequence xn is divergent. Okay, with this scheme. So I am taking that for fourth option, option D. Okay, I am taking x0 equal to root 2. Then what happened? x0 root 2 is a non-zero real number. Okay, from this scheme x1 equal to x0 by 2 plus 1 upon x0, right? What is x0? Root 2 upon 2 plus 1 upon root 2. This become root 2 by 2, means 1 upon root 2 plus 1 upon root 2. Okay, so this become 2 into 1 upon root 2, so we become root 2. So we get x1 equal to root 2 if we choose x0 equal to root 2. Okay, now, so if we choose x0 equal to root 2, then we get x1 equal to root 2. Now, if it's x1 equal to root 2, then what is x2? With this scheme, put x equal n equal to 2, so we get x1 2 minus 1 1 by 2 plus 1 upon x1, right? Now x1 is root 2, it is root 2, so put root 2 by 2 plus 1 upon root 2. This again become root 2 by 2 means root 2, 1 by root 2 plus 1 by 2 means 2 by 2, 2 by 2 means against root 2. Okay, so x1 is root 2. If x1 is root 2, then we get x2 equal to root 2. x2 is root 2. Similarly, if x2 is root 2, if x2 is root 2, then with this put n equal to 3, you get x2 by 2 plus 1 upon x2. Okay, so you get root 2 by 2 plus 1 upon root 2. This again give you root 2. Okay, so if x2 equal to root 2, then you get x equal to root 2, like so on. In this manner you get a constant sequence. Okay, so if I write the sequence, then what is first term? Root 2, second term root 2, third term root 2, fourth term root 2. So it is a constant sequence. It is a constant sequence. In constant sequence, it always converges to a constant value. What is the constant value? Root 2. So this sequence converges to root 2. So if I choose x0 equal to root 2, which is non-real number, then with this scheme the sequence xn converges to root 2. But option 4 says for x0, for any x non 0, the sequence xn is divergence, but it is not true, right? It's a divergent, but I get convergence. converges to root 2. If I choose x0 equal to root 2, then the sequence converges to root 2. Sequence is a constant sequence and it converges to root 2. Okay. If we choose x0 equal to root 2, then we get the sequence like this: root 2, root 2, root 2, root 2. So it's a constant sequence. Okay. A constant sequence always converges to constant value root 2. So option D is not correct. Okay. Anyhow, now option A, B, C. We analyze now option A, B, C. Here says x0 converges to root 2 for x0 belongs to non-zero real number. And here it says x0 greater than root 2 by root 3. Okay. Here says x0 belongs to open minus 1 with non-zero. Okay. So I am taking any non-zero. So for option A, B, C. For option A, B, C. See what I will do now. For option A, B, C. Okay. A, B, C. This option. A, B, C. For option A, B, C. What is the scheme? Xn equal to xn minus 1 by 2 plus 1 upon xn minus 1 for n greater than 1. Right? See, I am choosing x0 be any real number, non-real number. Okay, I am choosing n general non-real number x0. Okay, let x0 be any non-real number. Now, see, giving it 1. From here, I can write with this scheme. If I calculate some more step, then I get this: xn equal to xn minus 1 the square plus 2 upon 2xn minus 1, right? I get this. Multiply this cross, so you get 2xn xn minus 1 xn square plus 2 xn minus 1 square plus 2. Okay, so take this left side, you get xn minus 1 plus 2xn xn minus 1 plus 2 equal to 0. Okay, you get this equation. Now this is a quadratic equation. It is a quadratic equation. In xn minus 1, right? It is a quadratic equation xn minus 1. So it is a 2 real root. Okay, quadratic equation in xn minus 1. So it has roots, and roots will be real because we know the sequence xn belongs to R for any n greater than 1. Xn belongs to R for any greater than 1. So its root, if we solve this, we get xn minus 1, right? Because it is a sequence, is a quadratic equation in xn minus 1. So if we solve this quadratic equation, we get xn minus 1, and xn minus 1 obviously belongs to R because xn belongs to R. Okay, so it is a real quadratic equation. So because the roots of the quadratic equation is this quadratic equation should be real. So a quadratic equation have root reals when the quadratic equation has real roots only if the discriminant is greater than 0, right? So for this quadratic equation, the discriminant should be greater than 0. Discriminant b square minus 4ac, b square minus 4ac. This should be greater than 0. So what is this? B or b is minus 2xn minus 1. So minus 2xn 4 a means 1, c means 2. So this should be greater than 0. Okay, if this quadratic equation have real root, so this one must be greater than 0. This one should be greater than 0. So from this we get 4xn the square greater than 4 into 2. So you get 4 n greater than 1, right? So you get xn greater than root 2. From here it is clear that root 2 greater than 1 greater than 0 means xn is a sequence of positive real number, right? Xn is a sequence of positive real number, and all xn are greater than root 2. Every xn for n greater than 1 greater than root 2 means root 2 is a lower bound of the sequence xn. Okay, so we get a lower bound of the sequence xn. Now we know a result. If a sequence have a lower bound, means the sequence is bounded below. So we are now going to try to prove the sequence scheme. With this scheme, the xn is monotone decreasing. If we know a result, if a sequence xn is monotone decreasing and is bounded below, then it's convergent. Okay, so now we are trying to prove xn is monotone decreasing. What we get? That we get, I'm writing in. sides. Okay, we get xn is greater than root 2. Okay, till now we get this. Now I am proving that the sequence xn is modern decaying. So for this I am calculating this x difference xn minus xn minus 1. Okay, calculate the difference. What is this? Xn, please write xn by 2 plus half xn minus 1 minus xn minus 1. Okay, so you get xn minus 1 the square plus 2 minus 2 xn minus 1 the square, right, upon 2 xn minus 1. Okay, so you get 2 minus xn minus 1 square, right, upon 2 xn minus 1. So 2 minus xn minus 1 the square upon 2 xn minus 1. Okay, right, you get this. See, if you replace here n and replace n by n plus 1, so you get you have to replace here n by n plus 1. Okay, so I'm replacing that. Replacing n by n plus 1, you get here n plus 1, here n. Here, similarly, after calculation you get here n replaced by n plus 1 means if you get here n, it will be n. Okay, so data I get, I'm writing, I get this expression xn minus 1 equal to 2 minus xn minus 1 the square upon 2 xn minus 1. This is true for any n greater than 1. Okay, now I'm replacing n by n plus 1, replacing n by n plus 1. So what do you get? Xn plus 1 minus xn equal to 2 minus xn square, right? Replace n by n plus 1. Lower part is 2xn. Okay, now see, xn is greater than root 2. This means xn square is greater than 2. Okay, for n greater than 1, this means 2 minus xn square will be less equal to 0 for n greater than 1. Okay, 2 minus less is 0, and xn is greater than root 2 means xn greater 0 because root 2 greater 0. Okay, so lower part 2xn greater 0, lower part is greater 0, and upper part is less equal to 0. So overall will be less equal to 0. Right, lower part is positive and upper part will be negative or 0. So total will be less equal to 0. Okay, for n greater than 1. This means xn plus 1 minus xn will be less equal to 0 for n greater than 1, right? This means xn plus 1 will be less equal to xn for n greater than 1, right? This means the sequence xn is monotone decreasing, right? This means the sequence xn is monotone decreasing. So xn monotone decreasing. So we get the sequence xn is monotone decreasing and bounded below by root 2. So from the result we know if a sequence xn is monotone decreasing and bounded below, it is convergent. Okay, and converges to it Nbhm. So from this result we can say that xn is convergent. Okay, from the result we can say that xn is convergent because xn is monotone decreasing and bounded below by root 2. Okay, since xn is monotone decreasing and bounded below by root 2, so it implies xn is convergent. Okay, and say xn converges to L. Say xn converges to L. Now it is obvious that xn never converges to 0, right? Because first term x0 is non-zero. Okay, and also the other term also non-zero. So this limit can never be. No, this limit may be 0 because the sequence 1 by n, every time is non-zero, it converges to 0. Okay, I cannot say that this time this limit is non-zero. I can say that this limit is a real number. Okay, this limit is a real number. So xn converges to xn converges to L, and L is a real number. Say I let this is a real number. Okay. Now it is true for n greater than 1, right? The scheme is true for n greater than 1. I am taking limit from both sides as n tends to infinity. Okay, so what I get, if it will take limit n tends to xn converges to L. Okay, Now xn minus 1 is a subsequence of xn. Okay, if you have any problem, you can do that. You can replace n by n plus 1. Replace n by n plus 1, then what I get? If I replace n by n plus 1, I get xn xn plus 1, I get xn by 2 plus 1 upon xn, right? Now I am assuming that xn belongs to L, so xn plus 1 is a subsequence of xn. Okay, it is a sequence of xn. And xn plus 1, it has less term because it started from 1 2 3 4 5 6, right? 1 2 3 x1 x2 x3 x4 x5 x6, but it started from x2 because if you put n equal to 1, it started from x2 x3 x4 x5 x6, so it is a subsequence. Xn plus 1 is a subsequence of xn. We know that a sequence belongs to a limit L, then every subsequence belongs to same limit L. Okay, we know this L. If a sequence belongs to a limit L, then every subsequence belongs to the same limit. So xn plus 1 would be converged to L, right? So limit xn plus 1 should be L because it is a subsequence of xn, so it converges to same limit of that xn converges. Okay, so I am taking limit both side, so I get xn limit xn plus L is equal to L by 2 1 upon L because xn belongs to L. Okay, so it is the left side L minus L by 2 is L by 2 1 upon L. Okay, so this gives L square equal to 2. Okay, so I get L square equal to 2. If L square equal to 2, then it imply L equal to plus minus root 2. Okay, but L never be minus root 2. I am saying that L never be minus root 2. So possibility of L will be either root 2 or minus root 2, right? But L never be minus root 2 because I have taken that first time x0 is the because we have xn greater than root 2 for n greater than. Okay, take this limit both side. I can take this limit both side. Okay, so this become limit tends to xn is root 2 for n greater than 1. Okay, but if we take limit x to minus root 2, so this gives root 2 minus root 2 and root 2, but it is not possible, right? It is a contradiction. Okay, if we assume the xn belongs to minus root 2, then this gives a contradiction. So L can never be minus root 2, so L always be plus root 2. So possibility L will be plus root 2. So what we get? We get L equal to limit xn belongs to a limit L, and L is plus root 2 for any x0 belongs to R. Okay, means x0 whatever may be real number except 0, L always this sequence always belongs to root 2. Okay, now I'm coming from option. What option? It says converge root 2 for any non-zero real number, right? So it is correct. Basically converge root 2 for whenever x equal to root 2. It is correct, but we have to take one option, right? So we have to take the best option. So option A is the best option. It says it converge root 2 whenever x belongs to root 2. It is correct. Okay, if it we get for any non-zero real number, it's converge root 2. So if it is x0 become x0 be minus 1 open interval x at 0, then also it is true, it converges root 2, but we have to take the best option. Okay, among this the best option is option A because it says for any non-zero real number x converges root 2. It's a sub interval. But it says x0 only greater than root 2 by 3 because x0 can be negative. If x0 can be negative, this inequality doesn't hold for negative real number. Also suppose x0 equal to minus 1, then also this sequence converges root 2. Okay, but it doesn't say this, so you have to cut this. Okay, all similar for this option. This says only x belongs to minus 1, 1 minus 0. This sequence converges root 2, but it's not true always. Okay, because if I choose x0 equal to minus 2, okay, if I choose x0 equal to minus 2, then also the sequence xn belongs to root 2. Okay, because we prove that for any non-zero real number the sequence belongs to root 2. So this option, we have to cut this option. Okay, this option also not correct. So only correct option is option A, converges root 2 for any non-zero real number. Okay, so I hope this solution help you so much. Okay, so thank you so much, and please subscribe my channel. Thank you.